Alrighty, here we are. Week 1, part 1, just getting warmed up. And first, we're supposed to evaluate the expression. So when we're dealing with exponents, you remember stuff like negative exponent means bring it down and change the sign. So that 2 to the negative 3 became 2 to the positive 3 in the denominator. Remember that 3 to the 0, anything to the 0 power is 1. So 2 to the third, 2 times 2 times 2 is 8. And we end up with 1 over 8. Number 2, both of these numbers are bases and receive the exponent of negative 1/2. So we have 4 to the negative 1/2 over 9 to the negative 1/2. Both of those get flipped, meaning 4 to the 1/2 comes down to the bottom, 9 to the 1/2 goes up to the top, or numerator. So 9 to the 1/2 power is the same as, I don't have my stylus here, so it's a little awkward. It's the same as the square root. So square root of 9 is 3, and square root of 4 is 2, 3/2. Number 3, we have negative 32 to the 2/5, and I'm going to write here, let's try that. So when we have an exponent of 2 to the 5th, that's the same thing as 1/5 times 2. So it's frequently helpful where you split the fraction up, 2/5 as 1/5 times 2. So we have negative 32 to the 1/5, and then all of that to the 2. This came from this. Negative 32 to the 1/5 is negative 2. So we can say the fifth root of negative 32 is negative 2, because 2 times 2 times 2 times 2 times 2. 5 of them, that's right, equals 32. And then we have negative 2 to the second power. Remember, negative times negative is a positive, and we get 4. We're going to see this a lot, these fractional exponents. Break them up like that. Number 4, so here we have some square roots, and we are simplifying. So first we're going to break them down, where 32, we're looking for two numbers that multiply to 32. It's helpful because this is a perfect square. So square root of 16 is 4, and square root of 2 stays as square root of 2. 18 similarly gets broken down into root 9 times root 2, and square root of 9 is 3 times square root 2, and so we have 4 root 2's plus 3 root 2's. Because the square root is the same, we can combine them to 7 square root 2. Number 5. So it gets a little trickier when we're dealing with variables under the square root, but look at how it broke this down. I have the number, and then the variable, and then the variable. So x to the third, because this is the square root, meaning to the 1/2 power, I'm looking for multiples of 2 or even numbers. So x to the third I broke down into x squared times x to the first. That's helpful to us because the square root of x squared is just x. So this is a perfect square. So is 25. So 5x comes out of the square root, and we still have x in the radical sign. Similarly, x to the fifth can get broken down into x to the fourth times x to the first. There's a hidden little 1 right there. And then the square root of x to the fourth is x to the second. X to the second times x to the second is x to the fourth. Or you can think about 1/2 times 4 gives us 2. So we combine these, and we have 5, this should be 5x, shame on me, plus x squared times, or quantity times square root x. So don't forget about that guy right there. Number 6. So again, negative exponents move and change the sign. I think what I did here first, though, is when we're multiplying the bases, we're going to add the exponents. So 9 plus negative 2 is 7. And then when we are dividing the bases, we subtract the exponent. So we end up with a to the 6th. And down below, I showed that the other way we could do this would be to bring this down first, turn it into a to the positive 2, and then we'd have a to the third, and then we'd subtract exponents and get a to the 6th as well. So with these, frequently there are a number of ways you can do them. Just stick with the rules of exponents and you can't go wrong. Here I'm taking the b to the negative fourth and moving it down, and a to the negative 6 and moving up, so they become positives. And then we're combining, so we're multiplying bases, add the exponents, multiply bases, add the exponents, and lastly 8 divided by 2 is 4 in the numerator. Voila! Okay, next page, let's see. Got all this beautiful work. Alright, so we're simplifying, we have square roots again. What am I saying? I'm saying fifth root is the same as the 1/5 power. So this is like x to the 10th to the 1/5. And here we have exponent to exponent, so we multiply. 10 times 1/5 is 2. This is x squared. Number 9. Whoa, square root of square root. So you can think about square root, again, as to the 1/2 power. So we have something to the 1/2 power to the 1/2 power, and 1/2 times 1/2 is 1/4. So taking the square root of the square root is like taking the fourth root. So like we did in the previous page, we're going to break this down where we have the number to the 1/4, and then this x to the 5th, I'm splitting up as x to the 4th times x to the 1st, because x to the 4th is a perfect fourth root. So the fourth root of 16, 2 times 2 times 2 times 2 is 16, so that's 2. Fourth root of x to the 4th is x, and the fourth root of x is fourth root of x, and that stays under the radical sign. Number 10, so here we have the cube root of the square root of something. So cube root of square root of something, I think up here, right, cube root of square root, so that's the 1/6 power. So we're taking the 6th root, and we're also going to pay attention to the fact that 2 times 2 times 2 times 2 times 2 times 2 is 64. Okay. So based on that, we have this to the 1/6 power, so I broke it up, the number to the 1/6, and then the variable to the 1/6. And notice how this x to the 6th I left as just x to the 6th. I didn't break that down to x to the 4th times x to the 2nd or whatever, because this is a perfect 6th root, meaning 6 times 1/6 gives us just first power, x to the 1. So we have 2x. I like that nice simple solution to a complicated. And then let's see, hint, simplify means eliminate negative exponents. All right. So what do we have? It's a little messy here. This is to the 3/2. So we have all this stuff being raised to the 2/3. So 8 to the 2/3, a to the 6 to the 2/3. Notice how exponent to exponent, we're multiplying the exponents, and b to the 3/2 to the 2/3. So exponent to exponent, multiplying the exponents. 8 to the 2/3, so this is here that fractional exponent again, where we have, if we split 2/3 up into 1/3 times 2, then 8 to the 1/3, 2 times 2 times 2 is 8, so the third root, I'll write this additional step, third root of 8 is 2, so we end up with 2 squared, which is how we get that, 4. 6 times 2/3 is 4, right? 6 over 1, canceling. And 3/2 times 2/3 is 1. So we have 4a to the 4th b. And number 12, we have some stuff to the negative 1/3. So I think in essence, we're distributing the exponent. Each of these things receives the exponent to exponent. So we multiply 4 times negative 1/3, negative 4/3. 6 times negative 1/3, it's going to be negative 2. And then we're writing this without negative exponents, so both of these move to the denominator. Remember, there's a 1 up there as a placeholder, And so we have 1 over d to the 4/3 f to the second. Rationalize the denominator. So rationalize basically means get rid of square roots. So whatever we have in the denominator, we're going to multiply by some square root or some radical so that there are no longer radicals in the denominator. Turns out x squared times x squared is just x, which is down there. So this, we just sort of pull this out of our hat and say, hey, I'm going to multiply by this over this. Square root x over square root x is just 1. So, excuse me, by multiplying this by 1, I don't change the value. So, we have square root 2x over square root of x squared. And what happens is that this turns into just x. And so, I know this doesn't look any more simple than this, but in math speak, it is simplified because there are no longer radicals in the denominator. We have rationalized this step. This is called rationalizing the denominator. So based on whatever the denominator is, we multiply top and bottom by that, essentially. So, for example, I know I just skipped 14. We'll go back. We have square root 12 in the denominator, so we multiply both top and bottom by square root 12. Square root 12 times square root 12, you could skip this step, is just 12. And square root 60 simplifies to, let's see, did I say 4 times 30? Who's in charge here? This is 4 times 15. Shame on me. 15, and so this would be root 15 over 6. Let's see if I got that other part right. 4 times 15 is 60, square root 4 is 2, and 2 over 12 gives us, or simplifies to 6. Okay. A little early, I guess. So let's go back to this other one. Here we have not just the square root of something, but this actually ends up being, we have the 4th root and y to the 3rd, so it's like this, y to the 3/4. So multiplying the denominator by y to the 3/4 wouldn't really help us, because we'd end up with y to the 3/4 and y to the 3/4, and when we add these exponents, we wouldn't end up with y to the 1. So notice how I chose 4/3 here, 3/4. Okay, little glitch there, found a typo. So we have y to the 3/4, and what we would multiply by is y to the 1/4. Because when we're multiplying bases, we're going to add exponents, and 3/4 plus 1/4 gives us 1. And this mistake I made here, I was thinking I was going to be multiplying the exponents. Shame on me. So I'm adding exponents, 3/4 plus 1/4 gives us y to the 1. The denominator will be rationalized, and we have to multiply top and bottom by that. Let's see what happened in this next step. Aha, so covered that up. And up top we have 1 times y to the 1/4. And down below we have y to the 3/4 times y to the 1/4. So these exponents are being added. 3/4 plus 1/4 is y to the 1. And so our answer ends up being like this. Y to the 1/4 over y to the 1st. We could write this as y to the 1/4 over y. And we'd like to not have fractional exponents in the denominator. If we were to subtract, we could get this, 1 over y to the 3/4. And I know that this looks a little simpler than this, but no negative exponents, and try to avoid having fractional exponents in the denominator as well. So there we go with that, and we're done.